All right, so section 2.4 is surveys and cardinal numbers, and the first thing we're going to look at is the one and almost only formula that we've looked at all so far in this chapter. You saw one other formula. It was for subsets. Do you remember that one? It was 2 to the n power. So this is our second formula and last formula for this section. And this formula says the following. If you're trying to find out the number of items in the union of two sets, what you could do is you could count the number of items in one set and count the number of items in a second set, add those numbers together, and then subtract the number of items in their intersection. In order to make sense of this, I want to draw a picture of what's happening if you actually go through this process. So we've seen this Venn diagram idea before. This is set A and set B, and we're going to call this the universal set on the outside, set U. If I did from a visual perspective, you can think of this like maybe as area. Okay, let's just talk about the area or the space that's there. If I wanted to know how much space is there in this whole union, because that's the union, right? All that space. One thing I could do is I could measure the space or the number of items or however in set A. Okay, that's what this is saying to do. Find how much is in A. And then I could do the same thing in B. I could say, well, how much of stuff, area, numbers of items, whatever, is in set B. The problem is, while I've shaded everything when I did that, what did I also do?
Shaded the intersection twice.
I shaded the middle twice, didn't I? This sort of got double counted. It got counted when I counted A, and it got counted when I counted B. So anything that was in this overlapping section got counted twice. So I have to remove the double count, which is why we have minus the intersection one time here at the end, because the intersection got counted twice. Does that make sense? All right, so I'm going to go a little bit out of order on your notes, and I'll apologize for that, but I think it'll make more sense. I'm going to skip the first example, and we're going to jump on down here to example 2, where it actually makes use of this formula, okay? So this says make use of an appropriate formula, and like we said, we only know 2, right? And this is the one that we were just looking at, to answer the question that was asked. This one actually asks you to find the number of items in the union if these other 3 pieces of information are known. So the formula that we're going to use is that one that was just on the previous slide. But what I want you to make, or want to make you aware of, is that while this one's kind of friendly in the sense that it asks you to find the thing on the left and it gives you the 3 things on the right, it really doesn't matter which 3 pieces of information it gives you. It could just as easily have given you this value and this value and this value, right? And asked you to find this piece, the number of items in B that are missing. Are you with me? So I don't care really which 3 pieces of information I'm given. I'm going to be able to use this formula. So let's fill them in as they were given to us. We do not know the piece on the left, correct? That's the one that we're asked to find. But I do know the number of items in A. So how many items are there in A? What's the number of items in B? And what's the number of items in A intersect B? 5. So we can add 8 plus 14 minus 5, and I get 17. So the answer to the question asked on this problem is the number of items in the union is 17. Make sense? All right. Let's go back to the, did everybody get that written down? Okay. We're going to go back to the one that I skipped now, okay? If you've got all of the information given to you in a picture, it's often very helpful just to use it as it's been given to you. So we're going to fill in some pieces of information, and the first couple we've kind of talked about how this works before, and then after that we've done it a little bit differently than we'll do today, so we'll take a look at another perspective. Part A asks us to find what? The intersection. And in terms of my picture, what is the intersection's description? What am I looking at or looking for? What they have in common or where they overlap, right? And that number on this particular picture is the number 6. So the intersection here is 6. Part B, however, asks me for the union. And union means what? everything. So I get everything listed. I don't even need a formula for this one because you can look at this and you can tell me, what am I going to add together? 3, 6, and 2. All of those are the everything we just talked about. So 3 plus 6 plus 2, and you don't have to write that piece down, but just so that everybody's seeing where those numbers came from, is what? 11. So the number of items in the union is 11. Okay. I want you to notice on C, D, and E, what symbol is on all three of those? What was it? Yeah, that's true too. Both of them actually. I was talking about the second thing that you just said. The intersection symbol is what we're using here, right? So on C, I'm going to find an intersection. On D, I'm going to find an intersection. And on E, I'm going to find an intersection. But it's an intersection each time of different sets. This set is A complement. What does A complement mean?
Everything that's
Outside of A. So looking at this picture, what values do you see outside of A? 2 and 7. Okay? And we want to know where that intersects set B. Just the number 2, right? One little piece. So this is the number 2 down here. Now, same idea on this one, but this one actually has the notation actually opposite. This says set A. So what values are in set A? 3 and 6. And we want to know where that intersects 3 and 7, B complement, the things that are not in B, right? So this question is in essence asking us what is in circle A and not in circle B. And that number is 3, right? And then this last piece right here, in language, what is it asking me to find? Not quite, Alice, you're close. Okay, that was pretty good. You worded that very interestingly, but it is correct, yeah. So everything that's not in A and everything that's not in B at the same time, right? At the same time. So what value or values is everything not in A and everything not in B at the same time? 7. It's just the number on the outside, right? So you can do this with shading, right? You could do this with the values. Now the difference here between what we did last time is these numbers that you're seeing listed here, while they're very nice because they're all different and we can kind of talk about it the same way we did last time, these numbers are not representing just sort of the region that we're talking about. They actually represent how many items are in that place. So in other words, there are 3 items right here. There are 6 items that are in the middle, and there are 2 items over here, and there are 7 items in the outside. So we're going to use that idea, and we're going to look at another problem. Now this problem does not actually have the Venn diagram filled in, but it gives us a whole bunch of information on how to do it. All right? So first question, anytime you're asked to draw a Venn diagram is, how many circles do you need? And how many circles do you need on this one? 3. So we're going to draw 3 circles. And we'll label them just like we did last time, A, B, and C, since they're labeled that way in the problem, with a U on the outside. Okay, so far so good? All right. Now here's the thing that's different. We're not just going to put 1 through 8, because we're given some information about these circles. For instance, let's take the first piece. The number of items in A is 24. Now, the problem with that piece of information is that that's talking about the entire circle A. And the entire circle A is made up of 4 different spots inside of A. I have this outer piece right here. I have the part where it overlaps circle B only. I have this part where it overlaps circle C only. And I have this part in the middle where they all 3 overlap. So unless you just want to do a lot of trial and error, you do not want to start with the number of items in A being 24 and sort of guess at what numbers might go where. Because that's a lot of guessing, right? I mean, you probably would be at it all day if you just randomly guess with this. So for the same reason, starting with the number of items in B or the number of items in C is not going to be helpful. Now let's go to the next piece of information because we're getting closer. This one right here says that the number of items in the intersection of A and B is 10. So here's circle A and here's circle B. But their overlap where they intersect is still made up of 2 pieces, right? And between those 2 pieces, I need to have 10 items. Maybe it's 10 and 0, maybe it's 0 and 10, maybe it's 5 and 5. I don't know. There's still a lot of choices, and I don't want to do trial and error. You with me? Okay, so 2 overlapping circles, still not enough information to actually decipher exactly where I want to put my numbers. So if I keep going along, here's 2 intersecting, here's 2 intersecting. This piece, however, tells me where they all 3 intersect. And there's only one location where they all 3 intersect, right? It's right in the middle. So I can use that piece of information. That's the number 6, and it will go right here. Does that make sense? Now, so I've used this piece. Alice has already told me what I want to do next. What do you want to do next, Alice? Okay, you want to jump. All right, up to here then, right? Okay, so if we jump back up to this one, and I'll just underline them as we do them, then I can look at the intersection of A and B. It has to add up to the number 10. And I've already got 6 of them here, which means how many go here? 4. What next piece do you want to do?
No, you're going to do C and A.
Okay, so let's do C and A next. Sure. All right, so C intersect A is 15. So A's here, C's here. And these 2 pieces are where they intersect. What piece goes on the outside? 9. That's not a good 9. That's better. So this 9 and this 6 add up to 15, which is what they're supposed to add up to. Is everybody with me? Is it okay? We have one more overlap. I'm not going to go back to circle A just yet. Let's do the other overlapping piece before we do that, okay? So there's one more piece where the circles overlap, and that's B intersects C. So here's B, and here's C. These overlap in 6 in this place, and they're supposed to add up to 8, which means how many's in the piece missing? 2. All right, great. Do you do A, B, or C next? A. Mackenzie says A. All right, A. All right, so circle A right here is supposed to all add up to what again? 24. Right now I've got 4 plus 6, which is 10 plus 9 is 19. How many are missing? 5. So I need 5 on the outside here of circle A. Okay, so I've done this one. How about we do B next? Is that all right? Okay, B is another 24. So I'm supposed to have 24 over here. I've already got a 4 plus a 6 is, plus 2 is, and so I'm missing 12. Excellent. And the last piece of the individual circles is the number of items in circle C down here, and it's supposed to be 26. I have 9 plus 6 is, plus 2 is 17. How many are missing to get on here? 9. Good. All right, but I'm not done. What's missing still? Okay, well, I haven't used a piece of information, but what's missing from my picture? The part that's outside of the circle still in the universe, right? In the universal set. So this piece right out here is what's missing. Make sense? That number's not 50, though. So how do we figure out what that number is? Right. So this piece right here, the one piece we haven't used, is telling you that the number of items, all of them inside of the rectangle, have to add up to 50. Right? They don't yet, but they're going to soon. So we're going to add these pieces up. So how about this? We know everything inside of circle A was 24, right? All right, so this is 24, plus 12 more is 36, plus 2 is 38, plus 9 is 47. You guys are pretty good at adding. 47? How many are missing? 3. So there's going to be 3 out here. So the key to working these usually is from the inside out. It doesn't always work out that way. It kind of depends on the information given. But often it works out that way. All right? What's different about the next example? What was it? There's words, right? That's exactly what I'm going for. There are words. The last one didn't have any words. It had lots and lots of symbols. You may have hated the symbols. But now you've got words that you have to turn into symbols, kind of. So I'm not sure it's any better, but at least there's some context so you can see how this works. All right, we're going to use Venn diagrams to work the problem. Let's read the problem first. Joe writes and produces albums for musicians. Last year, he worked on 10 such projects. He wrote and produced 2. He wrote 5. And he produced 7. Okay, everybody following so far? Okay. First question then is, if I'm drawing a Venn diagram, how many circles do I have? 2. And what are these circles representing based on this information?
Vote and produce.
What he wrote, so we'll just label it that way. And what he... All right, so I'll just write product, top, produced. Where am I going to start?
The middle.
All right, so do you know from this piece of sort of descriptive data, what is in the middle? 2. Because it says he wrote and produced. And is one of those words that means intersection. Both of them happening at the same time. So in the middle is the number 2. Okay? And then we can go to either side next. How many did he write total? 5. I've already got 2 in the overlap, so how many more need to go in circle wrote? 3. So that they add up to the circle 5, right? And then how many did he in total produce? 7. There's 2 in the middle, so there's 5 on the outside. I still need a number outside in the universal set, sort of outside the circles. It's a 0. Because this whole U is supposed to represent all of the different projects he worked on. And it said he worked on how many projects? 10. And I already represented all of them in my circles, right? So there isn't anything left, which means the number 0 goes on the outside. Once we've drawn the picture, the questions are based on the picture. So if you mess up the picture, it's okay. I mean, you'll lose points for the picture part. But the questions at the bottom need to be based on whatever your picture shows. So even if you can't fill in the question or in all the pieces right, you got to fill them in with something or you can't answer the questions. Does that make sense? Okay. So the question first, part A, asks, how many projects did he write and not produce? 3. It's the outside of the circle on the right. How many did he produce and not write? 5. And how many did he neither write nor produce? 0. Straightforward enough? What's different about this problem? Let's read through it, and then I'll answer that question again. Okay, let's read it. Let me read it. At the University of Louisiana, half of the 48 mathematics majors were receiving federal financial aid as follows. 5 had Pell Grants, 14 are in college work study, 4 had TOPS scholarships, 2 had TOPS scholarships and were in work study, and then lastly, those with Pell Grants had no other financial aid. What is different about this problem than the last problem? There are 3 circles, right? And what do those circles represent with this context? All right, so one of them was a Pell Grant. What else did I have? So work study, I'll call it WS. And then, yeah, TOPS scholarship specifically, right? So let me write TOPS. Okay, so what are we going to start with? There's a couple of different things we could start with. This problem's given to us a little differently.
Did you start with the outside number?
Can't start with the outside number because we don't know that yet. We weren't told. There's one piece of information that is just so extremely useful. Okay, so that's a piece of something, Alexis, that's true. So this right here, there's 48, and it tells you that half are receiving funding, right? Federal funding, specifically. They may have other kind of funding, just not federal. So let's make a note first that 24, half of them, have funding. That actually tells us that the universal set, all of it inside the box, is going to add up to 24. So it's a useful bit of information, but we still can't start there. What about the Pell Grants is important, Kat?
If you have a Pell Grant, you can be other financially.
That's really helpful, isn't it? How many people had Pell Grants? 5. So if I'm looking on my picture, I can fill in the 5 for the Pell Grants right here. Because it said if they had a Pell Grant, they had nothing of the other sorts, correct? Which means, what else can I fill in automatically?
The intersection.
These 3 intersections, right? Oops. Yeah, I got them right. They'll have to be 0. So far, so good? Awesome. Now what can I use? Right, this piece right here tells you that there are 2 that had top scholarships and work study. So in my picture, where will that 2 go, Alice? Like there? Excellent. So there's a 2 in that overlapping piece. Let's talk about work study. How many total work study students did I have? How many? 14. And so how many have I not accounted for yet? 12. So there's 12 out here. How many top scholarship folks did I have? 4. So I need 2 more on the outside. And then somebody count up for me real quick. How many people are already in this picture? 21 or 23? 21. So I have 3 missing, yeah. There's 21 with 3 missing, so my 3 is on the outside. Because I needed 24, like Alexis said, right? You bet. Now I can answer the questions that were asked. First question, how many had no federal aid? 24. It's the 24 people I eliminated at the beginning, right? Yeah. How many had more than one form of aid? Just 2 of them. How many had federal aid other than these 3 types? That's my 3. And how many had a top scholarship or work study? Not and. The word's or. 16. So this is college scholarship, this top scholarship, 2. There's 2 that have both, and there's 12 that have only the work study, so we get all of those pieces for 16. Make sense? All right.